Mela. Let's check this one here. So as I've said in the previous video, we've got 7 sine squared x minus 5 cos x minus 5 is equals to 0, which works out perfectly for us because that 0 makes things easy. Means that everything has been isolated. All we have to do is to make sure that we work with the same ratio at least. And the problem is that here we've got sine squared x in the first term, and in the middle we've got cos x. We cannot change cos x. However, sine squared x can be changed because what we know is that sine squared x plus cos squared x should give us 1. Okay, because we don't want sine x, take this identity and isolate sine squared x. And when you isolate sine squared x, you will have sine squared x is equals to 1 minus cos squared x. Take this 1 minus cos squared x and substitute it into sine squared x. Note that we're substituting into sine squared x, not 7 sine squared x. No, we're substituting into sine squared x. 7 still stays there. All I did is that where there is sine squared x, I substituted that 1 minus cos squared x. Distribute that 7. 7 times 1 will give you 7. 7 times negative cos squared x will give you negative 7 cos squared x. Those are like terms. 7 minus 5 will give you positive 2. Get rid of that negative. I'm multiplying all the terms by that negative. And we've got 3 terms, which is negative 7 cos squared x. The second term will be minus 5 cos x. The last term will be plus 2. All 3 of them must be multiplied by negative 1. And obviously, they will just change signs. Note that because it has a ratio, people somehow find it difficult to factorize. Okay, I will show you that this actually looks exactly like this trinomial. How would you factorize this trinomial? It will be 7m minus 2 into m multiplied by m plus 1. And that's what we're going to have. Instead of m, we have cos x. Take each of those factors, equate them to 0, you will end up having cos x is equals to 2 over 7, or cos x is equals to negative 1. Because our ratio is cos, please note that when you find x, the formula will include plus or minus cos, the inverse cos. Please note that that is because cos is positive in the first quadrant and the fourth quadrant, which is the negative. It's like your angle of depression, sort of. It gives the negative angles, which is in the fourth quadrant, and that's why it carries plus or minus. The cosine, actually it will be arc cos of 2 over 7. And arc cos of 2 over 7, when you punch it into a calculator, let's see how much it will give us as a matter of fact. If arc cos of 2 divided by 7, it gives us 73.39, which is simply 73.4. Okay. It'll be positive plus or minus 73.4 degrees plus 360 degrees times k, where k is an element of integers. Some teachers don't like it when you show it as plus or minus, especially the negative part of 73.4. All you have to do is just to add it to 180 and it will give you an equivalent angle. All right. Obviously that is up to your teacher, but it's pretty much one and the same answer. Okay, they'll ask you to find a complement of that 73,4 instead of writing it as negative 73,4. But the complement and that negative 73,4 is one and the same angle. Okay, we are left with the second part where A is -1. We're still working with the ratio of cos, and therefore we'll have plus or minus arc cos of -1, and arc cos of -1 will be 180. That is our general solution will be plus or minus 180 degrees plus 360 degrees times k, where k is an element of integers. For practice, you can try this out. Okay, pause it and do it for 10 minutes. Here's the solution. Don't be confused by that 3x. Okay, treat it as though you will treat theta or x, or just substitute theta into, just say, let theta be equals to 3x. And then at the end, when you have solved for x, you substitute theta back, okay, if it confuses you. But it's pretty much the same as what we have done. Change the ratio that you can change to the ratio that you cannot change. Try this one out as well. Similarly here, you can let x plus 30 degrees be theta. And once you have solved for x plus 30 degrees, once you have solved for theta, substitute x plus 30 degrees where there is theta and solve for x. Here you were given an interval to work with. Remember to substitute relevant correct integers into k to find the angles that lie between -360 and 180 degrees. Okay. Okay, let's see the next one. This is similar to the previous one. Now try this one as well and check the next video for the solution.